So hi guys, welcome again to another video. So for our video for today is we're gonna be answering the chapter 8 activities, which entitled subnetting IP network. So let's start with the first activity. Here we are given a subnet mask in decimal format. Enter the binary representation of the subnet mask in the octet field provided and convert the mask to prefix notation format in the prefix notation head. So here we have our subnet mask. So for the subnet mask in binary, we will just compute the binary of this given subnet mask. So the 255 is the answer for the all octet. So the answer here will be all ones, because if we added the 1, 2, 4, 8, 16, 32, 64, and 128, the answer will be 255. Same in the second given number, we have also 255. So just like what I've said, the octet, the sum of all the octet has a sum of 255. So we'll be gonna put here 111. So next one, we got 252. So here we have 255. So in here we'll just minus 3. We'll just remove 3 because it's 252. So here we'll be gonna putting all 1, and then we remove the last and second to the last one and change it to 0 because we removed 3. So the value of the last number is 1 and the second to the last is 2. So that's 3. So we'll be removing 3 here in 255. So for the next one, we have 0. So that will be automatically all 0 because it's 0. So for the prefix notation, we will compute the all ones and add it, and we will put the answer here with slash, and we'll count this 8, 16, 17, 18, 19, 20, 21, 22. So the answer is 22. No. So let's check if the answers are correct. So that's correct. So let's try again for another number. So here there's a changes. Lately we have 255, 255, and 252. And here we have 255, 255, and 224. So in here we always put 111, like what I've said. The sum of all octets is 255. Same here in our second number. So here we have 2 to 4. So the answer there will be computing the value of 2 to 4 here. So we have 128 plus 64 plus 32, and we have 224. So the value here, the answer here is 111 because we use the 128, 164. We use 128, 64, and 32. And the following octets will be 0. So here again we have 0, so the answer is 0. So here again in the prefix notation we will just add the all 1. So we got here 8, 16, 17, 18, 19. So the answer here is 19. And don't forget to put slash on it because it's very important. So let's check if the answer is correct. So that's correct. So let's proceed to another activity. So we will be answering our second activity. We have determining the number of bits to borrow. So here we have the host needed, the subnet mask in binary, the subnet mask in decimal, and the prefix notation. So here we'll be using the host that given here to get the subnet mask in binary. So here we have 25, and we will be getting the sum that reaches 25. So the number that we use the number will be 0. So first we have here 111, and again 111 and 111. So here we will be computing the host to become the sum will be 25. So let's start from the last one. We have 1 plus 2 plus 4 plus 8 plus 16. So the answer here will be 21. So it reaches the host needed, the 25. So that value that we use, this one, we have the 1, 2, 4, 8, 16. That will become 0. So here we have 1, 1, 1, and the other 1, 2, 3, 4, 5, and the other 5 will be 0. So in getting the subnet mask in decimal, we will just convert the subnet mask in binary here to become a decimal. So the value of all ones is automatically 255. So the answer is 255 point, again 255, and another 255, and we'll be solving the 111. So the answer will be 128 plus 64 plus 32, and the answer will be 244. So we will put 224. Because we have 111 here, so we will just add the value of this one. So we got the 224. So in getting the prefix notation, we'll just add the all number here, the ones, and we'll put slash if we get the number. So we got here 8, 16, 24, 25, 26, 27. So the answer here is 27. So for the next one, just like this what I did here in 25, we'll put 111 and 111 here. We'll be getting the sum of that reaches 1000, and here we have this, all of this will be reaches 1000. So here we'll be computing this one, the 255.255, and the answer here will be 246. So, and for the next one, we have 0. So, we're just computing this again, the 8, 16, 24 minus 2. So, we got 22. So, in answering prefix notation, don't forget to put slash on it. So here we have the 75, we have 255, and we have 111 and 111, and again 111 and 10000. So here we will be computing here again, like this one. We have 127. So for the prefix notation, we will be solving this one, the 8, 16, 24, 25. So the answer here will be 25. So here for the 10, we have again 111 and 111 and 111 and 41 and 4000. So the answer will be here is 255.255.255.240. So the answer in prefix notation is 26. And again, we have 500, we have 111 and 111, 111 and 111, and we got 000. And here we have 255.255.254. That's 0 because it all started with 0. So here we have 23. So we'll just 8, 16, 24 minus 1. So that's 23. So let's check if the answers are correct. So let's see. So that's correct. So let's proceed to another activity. So let's proceed to the next activity. We have practicing the VLSM. So the instruction, the table 1 uses regular subnetting to accommodate the network shown. Table 2 uses VLSM to further subnet the network. Drag the addresses to the appropriate subnet description. So first, the prefix notation, we all know that the prefix notation uses slash and the number. So this will be the answer. So the new subnet mask in decimal will be always 255.255.255.192. So the next one, we have the first full subnet range. So that will be, the answer for that is, the first lowest in the last number. We have 63, and for the next one we have 127, and the next one is 255. The first full subnet range will be just the same as the given here in the second and last, but we focuses on the last numbers here last in the last this number. We'll be focusing on the smallest to largest. So that will be the answer. So let's check if the answers are correct. So that's correct. So let's proceed in figure 2. In figure 2, just like what we did in figure 1, it uses the same but different numbers given. So first we have the prefix notation will be /27, and the subnet mask will be 255.255.255.224. So again, for the first full VLSM subnet range will be based on the number for the first one we will be using the list number. So here we have 95, and for the next one, for the second one, will be basing, we have the same numbers in last, so will be based on the first given number here. So we have 64 and 98. 64 is the smallest, so that will be the second subnet range. So for the last one, we have 96, so that will be the last. So let's check if the answers are correct. So that's correct. So thank you for watching. See you again on the next video. So now we'll be doing subnetting, and we have here our IP address, the 192.168.1.0, and it is subnet mask from 24. So here we will borrow one here in the host address. We change this 0 to 1, and I change the subnet mask from 24 to 25. So if I convert this back to decimal, it is now 255.255.255.128. This can completely change the nature of the network. So we have now our 25 subnet. Subnet mask, and we have the 7 host bits. So starting from 24, now we have borrowed 1 bit from the host portion. This is the host portion, and we call this 1 bit a subnet, because if we look at it from the perspective we started in the 24. We've added 1 bit. So we could say that we have 7 zeros now. Host bits are 2 to the 7 power, 2 to the 7 power, and or equals to 128 minus 2, and the answer will be 126. So by borrowing 1 bit from the host portion of the address, we create 2 subnetworks. Just 2 subnetworks. Each subnetworks with 126 hosts. The subnetworks are the 192.168.1.0 and /25 net subnetwork, and now we have our one nine two point one six eight point one and 0.128. That's our new subnet, and with the subnetwork of 25. So we can prove that in this case using the ANDing to prove how router or computer would take IP address with the particular of 25 subnet mask and derive the resulting network address. So let's put in the host address, and the subnet is also from, I guess it's also a 2 because we have a 2 to the power of 1, and the answer here is 22. The answer is 2. So that's the subnet, and we have here 192.168.1 and 0.0 in the first one. Zero, and this will be 25 also. So that's the first one. So now I'll be teaching you the magic number. So now let's proceed to the subnetting by the use of magic number. So here we will just like what we did but lately, but by using the magic number we can easily identify the subnet here and the value of this decimal. So if we borrow 1 again from the host portion, and this will become 1 and 0 and 0 and 0 and 0 and 0, 0 and 0. So the value of our decimal here is 128. So if we borrow 2 bits from the host, we have 1, and this will change to 1, and our decimal here will be changed to 92 because we have here. So the magic number here is 64 because it is the increment of 64. So we have now our 192.168.1.0 in 26. Sorry, excuse me. So next is 192.168.1.64 also from 26, and also we have again 192.168.1.128 26, and we have 192.168.1.192 from the 26. Because why 26? Because we just count this binary, and this is 8, 16, 24, 25, 26. So that's our perfect notation. So I will end up here because there is a part that I understood this subnetting, but there is sometimes I don't know why that happened. So this IP address is just a basic. I used the basic one for us to know how does it work. So thank you for watching.